All right, so I just want to do just a few more examples, just in case you were struggling a little bit before you want to try your homework. So the first thing I want you to try to do, I'm going to give you an equation and see if you can graph it. So I want you to take a second and see if you can graph this. Okay, so f of x equals 1 over x minus 2 plus 3. So I'm going to ask you to pause and see if you can graph this with no calculator. So remember, what's our order of x? So the first thing is, who's my parent function? Okay. Second thing, what are my shifts? And then the third thing is put both of those together. Okay? So see what you got. See if you can figure out who's the parent function, what are the shifts that are taking place, and then put those things together and pause. Okay, so first thing, who's my parent function? That'd be 1 over x. So this is my rational function, 1 over x. So if 1 over x is my parent function, what are my shifts? What's happening here? Well, I see a plus 3 that's out in front. So that tells me that I'm going to go up 3 because this plus 3 is out in front of the function. So that's a vertical shift up 3. And then I see a minus 2, and it's right next to the input value. It'd be right next to this x, which means that's a horizontal change. Okay, so I subtracted 2 from the input, which means I'm actually going to go right 2 units. Okay, so now I got to put that together. So anytime I'm graphing these, the very first thing that I like to do is I like to graph my parent function. Okay, so we should be pretty good at graphing the parent functions, but I think graphing the parent function and then moving it around is going to be a huge help. If you try to do all this in your head, I think that when these get a little bit more complex, that's really going to mess some of us up. Okay, so let's see if we can graph this. So what do we know about our parent function 1 over x? Well, I know that there's a horizontal asymptote at 0. I know that there's a vertical asymptote at 0. So I know those two things. And then I know that my graph lives down here. No x-intercepts, no y-intercepts. And it lives up here. No x-intercepts, no y-intercepts. Okay, so that's my parent function 1 over x. So hopefully we know that pretty quickly now. So now all I have to do is move this graph around. So I'm going to start with up 3. Well, what's kind of nice about 1 over x, it seems like it might be the hardest one, but really it ends up not being too bad because we have these asymptotes that kind of guide our graph. So up 3. Well, what's going to happen if I go up 3? I'm going to take this horizontal asymptote and I'm going to move it up 3. All right. All right, so there's my new horizontal asymptote. And then this vertical asymptote, if I move a vertical line up 3, it just stays where it's at. So I don't have to worry about that right now. So that's all I got for up 3. Now, right 2. Well, what's going to happen if I move this graph right 2? I have this vertical asymptote that's at 0. So if I go right 2, now it's going to be at 2. So those red dotted lines, those are my new asymptotes. So up 3, right 2. And then how do I know where to put the rest of the graph? Well, remember, this graph just is going to hug these asymptotes. So it's going to hug my horizontal and vertical asymptote, and then up here, it's just going to hug the horizontal and vertical asymptote. So really all I did there was I just kind of changed the location of the axes. All right, now, if I want to take this a step further, let's be all-star students here. How could I find an x-intercept, and how could I find a y-intercept? Okay, so think about this. Y-intercepts. What do we know about any y-intercept ever in your entire life? Let's say I have a graph. What do I know about this? Every y-intercept that I could ever draw. Every y-intercept happens when x equals 0. Right? So when x equals 0, I'm going to have a y-intercept. So to find my y-intercept, all I'm going to do is plug in 0 for x. Okay? So I plug in 0 for x, I get 1 over 0 minus 2, so that'd be negative 1/2, plus 3, so I get 2 and a half. So my y-intercept is the coordinate 0, comma, 2.5. And if you look at your graph, mine wasn't perfect, but I was pretty close. So there it is, 2.5, that was my y-intercept. All right, now, the last part takes a little bit more work, but I'm going to find an x-intercept. So what do we know about any x-intercept ever in our entire life? Well, every x-intercept happens when my y values are 0. Okay, so all I have to do is set the equation equal 0 and then try to solve this. So let's see what we can do. So I'm going to set the equation equal 0. So 0 equals 1 over x minus 2 plus 3. So first thing I'm going to do is subtract 3 from both sides. So negative 3 equals 1 over x minus 2. And then I'll multiply both sides by x minus 2. Sorry about the glare. So negative 3 times x minus 2 equals 1. Distribute. Subtract 6. Divide by negative 3. So x equals 5/3. So this means that I have an x-intercept at 5/3, comma, 0. And if I look, 5/3, what is 5/3? 5/3 is 1 2/3, so more than 1 but less than 2. And if we look at my graph, that's right about where that was. Okay? So that would be the all-star way to do this problem. Start with your parent function, figure out the shifts, put it together, and then go back, find your x-intercepts and y-intercepts. Okay? So there's your first example. I'll come back in a second. And we're back. All right, so your next thing I want you to do is write the equation of this graph behind me. Okay? So if we follow our steps, this should be pretty straightforward, I think. So step 1, who's your parent function? Well, this is some sort of exponential function, right? I don't think without more information, there's no way for us to know what our base is, what that b value is that we talked about. So my parent function is f of x equals, we can go 2 to the x, you can go 3 to the x, you can go whatever. All right, sorry about that. So 2 to the x, it could be 3 to the x, it could be 4 to the x, it could be e to the x. So we don't really know for sure without more information on the graph, okay? Because any function that is of the form some value to the x is going to have a the same y-intercept, okay? So you can pick whichever base you want. I usually just pick 2 because it's a nice, easy number to work with. All right, so what happened with the graph? So we know our parent function. So what was the shift? Well, if you know your parent function, usually there's this graph flattening out at 0, and now it's flattening out at negative 3. So this looks like it was a shift down 3. Okay, so down 3, does that impact my inputs or my outputs? So that's impacting the outputs. So my new function, g of x, would be the equation 2 to the x, there's my parent function, and then minus 3 out in front because it's a shift down 3. Okay, so there it is. Now we could check this. How can we check to make sure that we felt like we were on the right track? Well, we have a good point right here. We have a y-intercept of negative 2. So how do I check y-intercepts? I plug in 0 for x. So if I plugged in 0 into my new equation, g of 0, that'd be 2 to the 0 minus 3. Anything to the 0 power is 1. So this is 1 minus 3, which is negative 2. So g of 0 is negative 2. And there it is right there. So I feel pretty good about my equation moving forward. All right, last example. So I want to write an equation for this function here. It's not perfect because I drew it by hand, but I think we'll get the idea. Okay, so first thing, who's my parent function? That's the first thing I want to know. So my parent function, this is a cubic graph, so my parent function is x cubed. That's step 1. Step 2, what shifts took place? So I gave you this point here. If you know your parent function, x cubed, usually goes through the origin. Now this point is at the coordinate 2, negative 1. So I went right 2, and I went down 1. function transformations out, I'm going to put together. So what is my new equation going to be? So my parent function is x cubed. So let's figure out this right 2. So what do I do with that? So right 2, that's a horizontal change. So that's going to impact my inputs. Okay? So if I go right 2, that means I really need to subtract 2 from the input value. So x minus 2 cubed, and then I went down 1, so that's going to be a minus 1 out front. Okay, so this would be my final equation for g of x. X minus 2 quantity cubed minus 1. Now, I have an extra point that I can check this with, so let's check. So my y-intercept is -9. So if I plug in what? I should get -9. If I plug in 0 for x, I should get -9. So let's try. So g of 0 equals 0 minus 2 cubed minus 1. So -2 cubed, so -2 times -2 times -2, that's -8. Minus 1 is -9. And so I got g of 0 is -9. That makes me happy because that's what my graph told me that I should have gotten. So I feel pretty good about my equation. Okay? So hopefully these examples helped a little bit. If you need any more help before you do your homework assignment, feel free to reach out to me and we can do some more practice together.